This video series is to accompany the Cisco Netacad Switching, Routing, and Wireless Essentials course. This video covers Module 11, Switch Security Configuration. In this video, we're going to look at the following 5 objectives: implementing port security, mitigating VLAN attacks, DHCP attacks, ARP attacks, and STP attacks. 11.1, Implement port security. Layer 2 attacks are some of the easiest for hackers to deploy, but these threats can also be mitigated with some common solutions. First, all switch ports or interfaces should be secured before the switch is deployed for production use. How a port is secured depends on its function. A simple method that many administrators use to help secure the network from unauthorized access is to disable all unused ports on a switch. Navigate to each unused port and issue the Cisco IOS shutdown command. If a port must be reactivated at a later time, it can be enabled with the no shutdown command. And then to configure a range of ports, use the interface range command. And here's an example here how to do that. Now, to mitigate a MAC address table attack, the most effective method to prevent MAC address table overflow attacks is to enable port security. And port security limits the number of valid MAC addresses allowed on a port. It allows an administrator to manually configure MAC addresses for a port, or to permit the switch to dynamically learn a limited number of MAC addresses. So when a port is configured with the port security, it receives a frame. The source MAC address of the frame is compared to the list of secure source MAC addresses that were manually configured or dynamically learned on the port. And then by limiting the number of permitted MAC addresses on a port to 1, port security can be used to control unauthorized access on the network. So port security is enabled with switch port security interface config command. And if you notice in the example below, the switch port security command was rejected, and this is because port security can only be configured on manually configured access ports or manually configured trunk ports. So by default, layer 2 switch ports are set to dynamic auto, and therefore in the example below, the port is configured with the switch port mode access interface configuration command. And this is a note here that trunk port security is beyond the scope of this course, and you'll learn it in later Cisco courses. We use the show port security interface command to display the current port security settings for Fast Ethernet 01. And we notice how the port security is enabled, the violation mode is shut down, and how the maximum number of MAC addresses is set to 1. And if the device is connected to a port, the switch will automatically add the device's MAC address as a secure MAC. And in the example on the right, no device is connected to the port. And if an active port is configured with the switch port security command and more than one device is connected to that port, the port will transition to the error disable state. So after port security is enabled, other port security specifics can be configured as shown in the example below here. You can set aging, MAC address, maximum, or violation. To set the maximum number of MAC addresses allowed on a port, you want to use the following command: switch port security, maximum, and then the value. The default value is 1. The maximum number of secure MAC addresses that can be configured depends on the switch and the iOS. And in the example on the right here, the maximum is 8,192. The switch can be configured to learn about MAC addresses on a secure port in one of 3 ways. First, you can manually configure, and you use the switch port security MAC address with the MAC address. You can use the dynamically learned. When the switch port security command is entered, the current source MAC for the device connected to the port is automatically secured, but it's not added to the running config. And if the switch is rebooted, the port will have to relearn the device's MAC address. And then finally, we have the dynamically learned sticky. The administrator can enable the switch to dynamically learn the MAC address and stick them to the running config by using the following command: switch port security, MAC address, sticky. And then you want to save the run config, and that will commit the dynamically learned MAC address to the NVRAM. The example on the right here demonstrates a complete port security configuration for Fast Ethernet 01. The admin specifies a maximum of 4 MAC addresses, manually configures 1 secure MAC address, and then configures the port to dynamically learn the additional secure MAC addresses up to 4. And then we use the show port security interface and the show port security address command to verify the correct configuration. Port security aging can be used to set the aging time for static and dynamic secure addresses on a port, and two types of aging are supported: absolute and inactivity. On the absolute, to secure addresses on the port, or the secure addresses on the port are deleted after a specified aging time. On the inactivity command or type, the secure addresses on the port are deleted if they're inactive for a specific time. So use the aging to remove secure MAC addresses on a secure port without manually deleting the existing secure MAC addresses. The aging of statically configured secure addresses can be enabled or disabled on a per port basis. And you use the switch port security aging, and this is the example down here below. The example on the right shows an administrator configuring the aging type to 10 minutes of inactivity. We get the switch port security age type activity. If the MAC address of a device attached to a port differs from the list of secure addresses, then a port violation occurs and the port enters an error disabled or error disabled state. And this is the command here: switch port security violation. And you have either shutdown, restrict, or protect. In the example on the right here, it shows the administrator changing the security violation to restrict, and then the output show port security interface confirms that the change has been made. When a port is shut down and placed in the error disable state, no traffic is sent or received on that port, and a series of port security related messages display on the console as shown in the following example below. The port protocol and link status are changed to down, and the port LED is turned off. In the example in the show interface command, the port status as error disabled is shown, and the output of show port security interface command now shows the port status as secure shutdown, and the security violation counter increments by 1. And the admin should determine what caused the security violation. If an unauthorized device is connected to a secure port, the security threat should be eliminated before re-enabling that port. And then to re-enable it, you just use the shutdown command and then use the no shutdown command. Now to verify port security, after configuring port security on a switch, you want to check each interface to verify that the port security is set correctly, and then check to ensure that the static MAC addresses have been configured correctly. The example indicates that all 24 interfaces are configured with switch port security command because the maximum allowed is 1 and the violation mode is shut down. And no devices are connected, therefore the current add or count is 0 for each interface. We can also use the show port security interface command to view the details for a specific interface as shown previously and in this example here. And then to verify that MAC addresses are sticking or being sticky, we can use the show run command as shown in the example here for Fast Ethernet 019. And then we can display all secure MAC addresses that are manually configured or dynamically learned on all switches using the show port security address command. 11.2 Mitigating VLAN attacks. So a VLAN hopping attack can be launched in one of 3 ways, and we've learned about this in a previous video, but we'll cover this here briefly. You can spoof the DTP messages from the attacking host to cause a switch to enter a trunking mode, and then from there the attacker can send traffic tagged with the target VLAN, and the switch then delivers the packets to the destination. You can also introduce a rogue switch and enable trunking. And then another type of VLAN is the hopping attack. Our VLAN hopping is the double tagging. And again, we covered that in a previous video, but we're just going to make note of it here in this video as well. This attack takes advantage of the way hardware on most switches operate. So first you want to disable DTP, auto trunking negotiations on a trunk port using the switch port mode. Step 2, we want to disable unused ports and put them in an unused VLAN. And then step 3, we want to manually enter the trunk line on a trunking port by using the switch port mode trunk command. And then we disable DTP by using the switch port non-negotiate command. And then we set native VLAN to a VLAN other than VLAN 1 by using the switch port trunk native VLAN and then the number command. 11.3 Mitigate DHCP attacks. The goal of a DHCP starvation attack is to use an attack tool such as Gobbler to create a DOS, or a denial of service, for any connecting clients. And we recall that DHCP starvation attacks can be effectively mitigated by using port security because Gobbler uses a unique source MAC address for each DHCP request. And then mitigating DHCP spoofing attacks requires more protection though. So as with all security, you want to have layers. So Gobbler could be configured to use the actual interface MAC address as the source Ethernet address, but specify a different Ethernet MAC address or an Ethernet address in the DHCP payload. And this would render port security ineffective because the source MAC address would be legitimate. So DHCP spoofing attacks can be mitigated by using DHCP snooping on trusted ports. So to do that, snooping filters, or DHCP snooping filters, DHCP messages, and rates the limits of traffic on untrusted ports. Devices under admin control, switches, routers, and servers are trusted. Trusted interfaces, trunk line server ports must be explicitly configured as trusted, and devices outside the network and all access ports are generally treated as untrusted sources. And so a DHCP table is built that includes the source MAC address of a device on an untrusted port and the IP address assigned by the DHCP server to that device. And then the MAC address and IP address are bound together, and therefore the table is called DHCP snooping binding table. There's 4 steps to this. We enable DHCP snooping by using the IP DHCP snooping global config command. And then on the trusted ports, we use IP DHCP snooping trust interface command. And on the untrusted interfaces, you want to limit the number of DHCP discovery messages that can be received using the IP DHCP snooping limit rate interface config command. And then finally, use the DHCP snooping by VLAN or by a range of VLANs by using the IP DHCP snooping VLAN global config command. So if we refer to the DHCP snooping sample topology with trusted and untrusted ports here, its DHCP snooping is first enabled on switch 1, and then the upstream interface to the DHCP server is explicitly trusted, and then F0 to F024 are untrusted and are therefore rate limited to 6 packets per second, and then finally DHCP snooping is enabled on VLANs 5, 10, 50, 51, and 52. Then we can use the show IP DHCP snooping privilege exec command to verify the settings. Then use the show IP DHCP snooping binding command to view the clients that have received the information. And then just a note that DHCP snooping is also required by dynamic ARP inspection or the DAI. 11.4 Mitigating ARP attacks. In a typical ARP attack, a threat actor can send unsolicited ARP replies to other hosts on the subnet with the MAC address of the threat actor and the IP address of the default gateway. So to prevent this type of spoofing and result in getting a result of ARP poisoning, a switch must ensure that only valid ARP requests and replies are relayed. So dynamic ARP, or DAI, requires DHCP snooping and helps prevent ARP attacks by not relaying invalid or gratuitous ARP replies out to other ports, intercepting all ARP requests and replies on untrusted ports, verifying each intercepted packet for a valid IP to MAC binding, dropping and logging ARP replies coming from invalid to prevent ARP poisoning, and then finally error disabling the interface in the configured DAI number of ARP packets or when it's exceeded. And here we're going to take a look at some implementation guidelines. So to lower the chances of ARP spoofing and ARP poisoning, you want to follow these guidelines. You want to enable DHCP snooping globally, enable the snooping on selected VLANs, enable DAI on selected VLANs, and then configured trusted interfaces for DHCP snooping and ARP inspection. And it's generally advisable to configure all access switch ports as untrusted, and then to configure all uplink ports that are connected to other switches as trusted. And here we have an example of DAI configuration. It will be configured to mitigate against ARP spoofing and poisoning. The DHCP snooping is enabled because DAI requires DHCP snooping binding. And then DHCP snooping and ARP inspection are enabled for the PCs on VLAN 10. And then the uplink port to the router is trusted, and therefore is configured as a trusted for DHCP snooping and ARP inspection. DAI can also be configured to check for both destination and source MAC and IP addresses. The destination MAC checks the destination MAC address in the Ethernet header against the target MAC address. The source MAC that checks the source MAC address in the Ethernet header against the sender MAC. And then the IP address checks the ARP body for invalid or unexpected IP addresses, including address 000 or 255.255.255, and all IP multicast addresses. The IP ARP Inspection Validate global config command is used to configure DAI to drop ARP packets when the IP addresses are invalid. It can be used when the MAC addresses in the body of the ARP packets do not match the address. And if you notice in the example here, only one command can be configured. So entering multiple IP ARP Inspection Validate commands overwrites the previous command. So to include more than one validation method, you want to enter them on the same command line as shown in the output to the right. 11.5. Mitigate STP attacks. So if you recall, network attacks can manipulate the spanning tree protocol to conduct an attack by spoofing the root bridge and changing the topology of the network. So to mitigate STP attacks, we use the Portfast and Bridge Protocol Data Unit, GUARD. Portfast immediately brings a port to the forwarding state from a blocking state, bypassing the listening and learning states, and it's applied to all end-user access ports. And then BPDU Guard immediately error disables a port that receives a BPDU. And like Portfast, BPDU Guard should only be configured on interfaces attached to end devices. So Portfast bypasses the STP listening and learning states to minimize the time that access ports must wait for STP to converge. Only enable Portfast on access ports, and Portfast on interlink switches or inter-switch links can create a spanning tree loop, so be careful. And Portfast can be enabled on an interface using the spanning tree Portfast we see in the example on the right-hand side. And then globally, we can use the spanning tree Portfast default. And then we want to verify whether Portfast is enabled or not. We can use the show run config begin span command or the show spanning tree summary command. And then we verify if Portfast is enabled using the show run config interface. And then we can show the spanning tree interface detail command can also be used for verification. And then finally, we want to look at configure BPDU guard. An access port could receive an unexpected BPDU accidentally, or because a user connected an unauthorized switch to an access port. So if a BPDU is received on a BPDU guard that's enabled, the port is put into error disabled state, and this means the port is shut down and must manually be re-enabled or automatically recovered through error disabled recovery calls psecure violation global command. And so on an interface using the spanning tree BPDU guard, or globally, we can use the spanning tree Portfast BPDU guard default, and we can see that on the right here in the example. So what did you learn in this module? Hopefully you learned a little bit. This is the first page. You can pause your video here to review these. And then finally we have page 2, and again you can pause your video here to read these.